Good day everyone. In this workshop I will give you a short overview of some methods that we developed for the automated image analysis of MRI scans using XNAT container services. So I will first start with a brief introduction of what XNAT looks like for those of you who are not familiar with this system. So here we see an example of what an XNAT project could look like. So we see we have 5 subjects, and then if we click on the first subject, we see that it has 1 MR session. Now, this is an overview of all the scans in this session, and something to note is that there is the series description, which is basically set as the scan type by default, but of course, this is not always very descriptive, which makes it hard to work with this data. And if we click on Manage Files, we see all the files in this project, which in this case are just the DICOM files, which is not optimal as often NIFTs or other formats are used to actually process the data. Therefore, it would be beneficial if you had methods that could already clean up and structure the data as soon as it came into XNAT, but also that we could analyze the data directly on the XNAT. Otherwise, we would have to download it offline, process it there, and re-upload the results, in which case we don't actually know what happened with the data in between. So let's take a look at how these automatic pipelines can work on XNAT. Here we see the data in the pre-archive. So this is where the data is initially uploaded on XNAT before it's actually made available to users. Now, if we archive all this data, it will run the automatic pipelines that we set up. If we now go back to the home page and look for this patient, we see that it has actually started the DICOM to NIFTY pipeline. So now, not only will it make available the DICOM to our users, but it will also provide the NIFTYs for all scans. If we now take a look at the patients, we see that whereas before certain fields were just left empty, because of the automatic pipelines, they have now filled in, for example, the sex, but also a clinical future of these patients. Looking at the scans of these patients, we see that it has automatically determined the type. So the type is now not just the series description. Actually, this type is automatically recognized from the scan appearance using Deep DICOM source, an algorithm that we developed. And these scan types are then stored according to the latest DICOM 2020E standards. If we look at the files, we now see that not only is there a DICOM file, there's also a NIFTY file that can instantly be used for processing. So now let's have a look at 2 applications that we developed for the processing of the data. The first application is an automatic registration tool. This registration is based on a logic. As you can see here, you can simply go to a scan, press run, and it will then automatically run the registration. As you can see, it is now running in the background. We will look at how to set up these processes and come back to the result of this registration later. These pipelines run in Dockers. This makes it very easy to install them, as they are already an environment that contains all the required tools and the commands. It is simply a matter of pulling the Docker image to the XNAT and waiting for it to install. We can specify the Docker name that we want and the version. This way we also have a version history and we know how the images were processed. We can now see that the pipeline is installed in the XNAT with a minimal amount of configuration step. We can now run this pipeline on a scan. If we now go to our scan session and we select the diffusion scan, we can see that there's the option to calculate the ADC from the diffusion. We can then run this pipeline in the background. The registration and diffusion analysis pipelines have been running in the background. If we now look at the files for this project, we see that there's a derived folder in the diffusion, where indeed we now have our ADC image. If we also look at the T2 where we went earlier, we will see that there is a registration to the atlas. These files are now ready to use. If you're interested in trying out these Dockers for yourself, please see our GitHub, where we also have the code for Deep DICOM sort, which can be used to automatically recognize the scan types. If you have more information or you would like to collaborate on developing new Dockers for XNAT, please contact me at s.vandervoort@erasmusmc.nl. Thank you for your attention.